Well, tonight's class, practical concepts for heating with solar energy. We think in terms of using the sun for all kinds of things. Matter of fact, we should. It's a wonderful, wonderful resource. And as always, I want to do it from a standpoint of teaching people the principles of how and why things work. So where does this class fit into this overall thing of self-reliant living? Well, as you know, there's quite a long list of classes that we have been working on, many of them published or on the website, more coming. In the shelter area, this is 6250, which is one of my favorite topics, actually, because my career in years past was in the area of solar consulting and design work. The mission is to teach people as much as we possibly can to just reach out and help people get concepts of these things. And it's about the principles of how and why things work. You see, provident living, I believe, has to be based on principles, an understanding of how and why things work, what the truth is really, not just lists of stuff. That's what's so important, because if you're just working off of a list or off of the library, so to speak, and it's not in your head and heart, then when you really need it, it doesn't just come up automatically. These 9 core preparedness modules I talk about all the time, everything that we teach is contained within them. All of the things you need to know, do, and have is contained within them. One of the foundational laws for anybody that's new, the law of provident living, I believe, is the most important one of all. It has 4 parts to it: spiritual, attitude, knowledge, and stuff. It has to be in that order. I talk in great depth about that in some of these other principles in other classes, but just to set the stage so you understand why I do what I do, we mention them very briefly here. The law of stewardship has 3 parts to it. I'm here because of stewardship. I believe you're here because of your stewardship to learn, to work in preparing for the future no matter what. The first part's authority, which we all have because we're alive. The second part is responsibility, and that is we have the right to act, and so we have to act. And number 3 is the one that we don't get to choose the outcome, basically. We control the outcome very often by what we do, but that's the accountability. It's the consequences of what we do and what we do not do. That's just simply how it works. This law of the parachute is such a simple concept, yet it's powerful. We think of a parachute and what it'll, well, if you have to have it before you really need it, you have to have it with you when you need it, you have to know how to use it, actually using it. It has to be of life-saving quality. Those 5 key points. If you can't answer yes to each one of those things when you jump out of a plane, it's simple, you're dead. Well, it really works the same way in the area of provident living, but in this case we're talking about your attitudes, knowledge, skills, and then stuff, the material things, the supplies and tools. Because the disaster doesn't care, just like gravity doesn't care once you jump out of a plane. If you don't have a way of intervening on gravity's job, it'll simply pull you down. So will the disasters and emergencies. There's a bunch of what I call these laws, the principles. 8 of them I talk about quite often. We just touched on 3 or 4 of them here very, very briefly. Now you can learn more about these principles on the website on safeharboralliance.com, the Foundation Class 1001, where we spend time digging into those deeper. You can go right to the website under webcasts, and then you go to past webcasts, and there you will find these classes, including the one I'm doing tonight. It'll be posted there shortly. The other place to learn about these is in a DVD. This is a 2-hour principle-based DVD that we sell inexpensively so that people can afford to get it. That's the Self-Reliant series, Part 1, the foundation, because it's the foundation principles that's most important of all. Well, in these 9 areas, we're talking about shelter tonight, and it is these practical concepts in solar heating. Is a wonderful topic. Actually, it's a lot of fun, and I enjoy working in this area very much. When we talk about heating, it's an important tool for self-reliance. We think in terms of warmth, which is for space heating. It also helps with independence, in this case, just from having to have the utilities all the time. It is about health. It's about physical, mental, and emotional well-being, not just because you have the independence, but depending on the type of sun space that you're using, they can be wonderful things to live inside of, and you'll see how that works as we go along. And then it can also help you with your nutrition, better quality and quantity of foods that our sun spaces and our heating spaces can produce for us. Well, we take a look at the way it is in our American life. You know, and we think of our heating and the comfort in our homes. You set the thermostat. As long as you keep paying the bills on time, the utilities keep showing up. You hire somebody for preventive maintenance. If something goes wrong, utilities break, you call somebody, they take care of it. You just keep doing what you've always done. And of course, a lot of people complain about the increasing costs. They do go up. But you enjoy this wonderful, comfortable lifestyle. And life in this country is great. It is wonderful. Well, is it always going to be this way? And just how sure are you that it will be? We hope that it will be. I hope that things continue in very positive and comfortable ways. Before we can really start heating with the sun, it'll be important to have an understanding of several things first, some concepts and ideas here. Solar energy. Well, some fundamental concepts to look at. Number one, the Earth, this spaceship that we ride upon that passes through space around us. Beautiful, wonderful planet, and we have this sun that shines down on it, you know, all the time. Someplace on Earth, it is being bathed with sunshine. Each morning, the sun arises, a picture that I took back in 1966 of a sunrise where I used to live. And we see that sun come up and it pours out this wonderful energy. Even in the depths of winter when it's cold, it's such a pleasant thing to have that sun shine upon us. Well, we think very often that we have to have, you know, bright, clear, sunny skies. And certainly there's more energy that way, but please understand that even when it's overcast, as long as you can cast a shadow, you can be capturing some usable energy depending on the kind of system that you have. When we take a look at solar energy, we're going to use it primarily for two things. One would be for space heating, and the other one would be for electrical power. Now, we're talking about, say, space heating and not the electrical power. That's a class I'll do at another time. When we take a look at these basic concepts dealing with solar heating, there's really two types of systems. There's an active system and there's a passive system. When we talk about an active system, it'd be an active solar heating system. This is one where you use electricity and other motive forces that help you to select, control, activate systems and equipment, the things that are going to be collecting the energy, going to be storing the energy, and will be distributing this thermal energy where you would want it. So you have these active components, and it's using power of some sort to make it work. So you have things with the pumps and the valves and thermostats and sensors and controls and solenoids, those kinds of things. These are a lot of fun, particularly for a guy like me as an engineer. I used to enjoy designing these things, and it's like all those fun little things that you can put in there that make it work. It can be enjoyable, but one of the disadvantages of that is the more components and pieces and controls and switches and valves that you have, that's more things to break, more things to shut down that you have to worry about maintaining. You take a look at a passive solar system, and for heating, this is one where the thermal energy just automatically flows by natural forces. In other words, you don't have to do anything to move that heat, capture that heat, store that heat. It simply works because it exists, because it's designed properly. So we take a look at a passive system, and this is mostly what I talk about because there's such tremendous advantages to a passive system, and this is where I've spent all of my design work through the years. I started out doing some things in the active area back in the 70s, and then very quickly decided, because of the complexity and some of the breakdown points in there, that I'd rather have something that will simply work because it exists. So there's things, when you understand how to make it work, you take advantage of the environment around you. One of the things that's critical for life on this Earth is this tilt of the axis of the Earth. It's about 23.5 degrees tilted off of vertical. That's what gives us the seasons. That's what gives us the variety that we have, and it also makes it possible for us really to have the variety of life that we have and the comfort that we have on this beautiful planet that was created for us. So we take advantage of the fact that we have this tilt, and what that means is that, and we all know this, the sun angle seems to change between summer and winter. You know, in the summertime, at high noon, the sun can be, well, directly overhead. It can be very high. In the wintertime, At high noon, it's going to be lower on the horizon. And of course, the further north that you go, the lower on the horizon it will be in the middle of winter. We take advantage of that to control the heat input in the winter, and of course then in the summer to exclude it. One of the other things that you have to pay attention to, particularly in a passive system, and that's about the heat losses that we have. It's first and foremost, it's about energy conservation. That lowers the cost of the things you have to add in. And this is really true with an active system, because if you have a house that's very leaky, not well insulated, lots of air infiltration and things like that, you have to make up for it by putting in larger equipment. In the case of a furnace that runs off natural gas, that's no big deal. I remember back in the 80s when I was doing a lot of solar consulting work and we were looking at retrofitting homes. I'd go to some homes that were built in the 50s, and some of these homes had some really high utility bills. That was back then in the 80s. You always see them now. And literally the attitude was, we'll just put in a bigger furnace. So they didn't do much with insulation, double pane windows, and all those things. It's just like natural gas is cheap, and a bigger furnace is cheap. That was cheaper than paying attention to those things. Well, we can't afford to do that anymore. And if you're going to be talking about having a solar system, you want to do these things, retrofit or build new, then conservation is extremely important. These key steps for a new solar home, some of the big things you pay attention to. First off, it's about the climate that the house is in. Now, that's both the macro climate, the big picture, the area in which you live, but you also pay attention to the microclimate, and this means the shape of the land and the trees and vegetation, the slopes and things like that will affect both wind and how early the sun comes up, things like that for you. So the macro and the microclimate is a part of the planning in terms of how you want to place your house on the property, its orientation. And orientation, of course, is a big one. If you're looking to heat the house in the winter, well, then southern exposure is what you want. If you live down in the desert southwest, you really don't need southern exposure. You're going to be more towards a northern exposure to help keep the house cool, especially in the summer. You want to minimize the air infiltration. This is leaks around windows and doors and cracks that you have in the house, and many of our houses are quite leaky, and that air infiltration sucks up an awful lot of energy. Window and door placement. The placement of the windows and doors will have a real effect on how well the system can work. It's all about energy conservation. High efficiency windows and doors, which means they're more expensive, but in the long run they pay for themselves. Trying to get the maximum amount of wall and ceiling insulation in. And then considering things like movable insulation, especially for windows. Windows that are nice gainers during the day can be losing a lot of heat at night, even when they're double and triple pane. So movable insulation can be useful. And then a big one, in fact, this is extremely important. It's something that people overlook, and that's an adjustment to your lifestyle thinking. We have a lifestyle right now that just allows you to set the thermostat and just let her go. And as long as the utilities work, the house can be maintained at a very comfortable setting. Of course, the prices keep going up because of the cost of utilities. And if you want to bring the utilities down and also use a system that may be completely off-grid, then adjusting your lifestyle thinking is critically important to get away from the concept that if my house isn't 72 degrees all the time, I'm unhappy. Now, if you want to retrofitting existing homes, there's some things that you don't get a chance to do. The home is already, sited and located where it's at. You do have to analyze things and be sure that it's even practical. In some cases, it may not be practical or be very, very expensive. The first thing you have to do in this case is adjust your lifestyle thinking. This is key, so that you don't have expectations that are out of line in terms of how much money you would spend and what the performance would be. So it's these correct expectations that will be very, very important, particularly for the amount of money you spend. Minimizing air infiltration is something that you do. So you take a look at possible window upgrades and door improvements, movable insulation for windows, and then can you get more insulation in the house, in the ceiling, perhaps in the walls, perimeter insulation around basements, things like that, that you may want to consider doing to conserve energy, because that's where you have to start. Well, reducing the loss of energy by all kinds of conservation methods is important. As a matter of fact, even if you weren't going to be adding some solar components to your home, then taking care of this heat loss would still be an important thing to do to reduce your utility bills. Now, all solar systems have three basic major components: collection of the energy, storage of the energy, and then a way of distributing those energy. So we're going to look at how some of that works, help you understand, because here again, if you're wanting to either build a solar home or retrofit your existing home, then the question will be, what can I expect? What is practical? What's possible? How much will it cost? So it helps to have some of these concepts in mind. Passive solar energy, just think of it as an automatic sun scoop. That's all that it is. Taking a look at some designs, I mean, there's a home in addition to a home that's just designed to scoop up that solar energy, bring it right inside. Here's another one of these sun scoops. Another one here, and we'll take a look at some of these homes a little more in depth as we go along, take a tour of a few of those. Just ways of bringing that energy into the home and being able to store that. Another one, some of these homes that as I have toured them and been around them in New Mexico, Arizona, Colorado, Utah, different ways, and you'll see different designs and different looks to these homes. Some of them very conventional in their look, some of them rather odd or strange in how they may in fact look. And you can even take existing homes and retrofit things to them, such as was done here on this home in Los Alamos, New Mexico. All right, so we're going to be scooping up some of this sun. That means we're collecting it. And here again, the focus is just in these passive areas rather than the active ones that have all these powered components that would be a part of them. The simplest way is we just take a look at what's called direct gain. Just directly gaining that energy right into the house. It is very simple. It's a very universal approach, and as a matter of fact, most houses are already doing that to some extent right now. It's just allowing some of this sun's energy to shine through a window inside where it can warm up some of the contents in there. And if you pay attention to how you do that, you can enhance the performance. So a window that just shines inside. This would be on the south side, obviously. Add more windows. Let them shine inside. Warm up concrete and adobe and brick and things like that. More windows that bring in this solar energy and this heat. Whole walls could be made out of windows as it would be appropriate. So that's the simplest way. Sunlight shines directly into the house, and your house probably does that right now. Unless you had no windows, except perhaps on the north side, you might not have any direct gain into the home. One of the other things to consider that's important is this idea of movable insulation. You see, when the sun goes down, when it stops shining for some reason, trap that heat that you brought inside, because these windows and doors, sometimes they can be real losers of heat, and so the overall gain is being reduced, or in some cases completely negated. It can be very simple and, quite frankly, very crude, just a panel of insulation that you will just stick in this doorway and over the windows come nighttime, or when it's very cold and cloudy, then you would simply plug that in and trap that heat inside. Now you can do something that's going to both look a little better and be a little more, well, socially acceptable, shall we say, and a much nicer way of doing it. In this case, we have fold-down insulation panels. They fold up out of the way, and come nighttime, you can see the cord that's hanging on the wall to the right there, and you can just lower these insulated panels down. It'll close off that window, trap the heat inside. You can have roll-down insulated curtains that would allow the sun to come in when they're up and then trap that heat inside. There's a variety of ways of doing this. The storage, and here once again in these passive solar systems, how do we store this heat? Well, a simple terminology, we call it thermal mass. And that's where we're going to store the heat in something that would be heavy mass. This is going to both store the heat, but it'll help stabilize the temperature within the structure to keep it from going too high and also to keep it from going too low. Well, when we take a look at this direct gain situation, if you have a concrete floor or a brick floor or a stone floor, something like that, allow the sun to shine in and just warm it up. That's the thermal mass. And you can also use soil and earth as a part of those things, of course, water and things. So floors very often are used, but you can also have walls. In this case, this is a thermal storage wall that's right inside of the glazing. This is sometimes called a trom wall also. And these are used very successfully within homes. Now here's a home in Cedar City, Utah. One of these sun scoops that's designed to snap up some of the sun, let it shine inside. And you see there's the thermal mass wall in the back of this room. As a matter of fact, this concrete wall extends right up through 2 stories in this home because it's sucking up heat that comes in the upper story as well as in the lower story, and other amounts of heat that would come into the house. You can see looking at it right here, it's very simple. It's just that concrete wall. The forms were removed. It's cleaned up a little bit. It's just been painted so that, in this case, a darker color so that it's better at absorbing the heat. Here's another thermal mass wall that's inside of this house using a partition wall, but in this case it's made out of concrete. That concrete will pick up some of this solar energy and store it, keeping the temperature in the room from getting too high, and then as the temperature in the room wants to drop down, it starts to give it back to the room. Here we have both thermal mass walls and floors within this home. Brick, and a nice way to do brick is to just put brick on sand. It doesn't have any mortar in there, compacted sand. This softens it up a little bit, by the way. It's not as hard as just a poured concrete floor because those bricks have just a little bit of give to them. You can use a brick or adobe in walls. Here's an adobe wall in one of our homes that just allows the sunlight to shine directly in on the adobe. In this case, the adobe is sealed with a varnish, so you're not getting any dust off of it, but just allow it to be exposed. It picks up that energy. You can use block and brick. In this case, you want to fill the brick with sand or with rock or with concrete inside, so you want just as much mass as possible, and you also have mass in the floors. Here again, more walls, and some of them can be very decorative, as well as having this dual function of picking up and storing energy. When we build some of these houses, we may use precast concrete panels like this that are then filled with sand or with rock. And in one of them we had these walls like this. We filled them with cobble rock inside of them, and then we were able to move air up through them also to be heating it. Here's columns, in this case steel pipe, corrugated pipe. Then these are both waterproofed in some cases, filled with water, or they may be filled with rock or with sand to give us this ability to store energy. In this case, it softens the glare of the sunlight because it breaks it up rather than having that entire window wall shining right into the house, which would be just an awful lot of sun sometimes. We have other strategies that can be used. In this case, barrels. To the right, you see the thermal panes. We'll look at actually the inside of this in a moment. You have direct gain up above where the sunlight shines into the room. You have these barrels on their side that are filled with water, and you allow the sunlight to shine on them and warm that up, and then the heat can circulate through them. Here's these drum walls with them exposed. This movable insulation that's on the outside in this case drops down to expose those barrels to allow the sun to shine on them. It also acts as a little bit of a reflector. It's aluminized on the one side, so it reflects sunlight up in there. Black barrels absorb the heat. They're filled with water. And then at nighttime, or when there's no solar gain, you see the latches up above, and these panels are simply, lifted up and closed up, so now you're trapping the heat inside. And then when we look inside, here is what's a countertop, and it has those drums underneath that, and of course then there's the direct gain above it. So these are simple things that could be done. This is a monastery up in northern New Mexico. Other ways of using drums of water, here they are in racks in a house. This house has movable insulation that's on the outside to close it up, but during the day when you can gain energy, those insulated walls are dropped down on the outside. Sun shines on the barrels, warms up the water. At nighttime, the walls are closed on the outside, and it traps that heat inside that's radiated into the room. It might even be something as small and simple as this, as just glass bottles filled with water in a window that will collect a little bit of heat and then be giving that back to the house. One of the things that's very important when you're dealing with passive solar is, of course, insulation is important. And if you're looking at basements, very often we just bury the basement and try to insulate them on the inside so that you don't feel that cold concrete. Well, the concrete's kind of cool because it's in contact with the earth that's running in 58 to 60 degrees. Where we have a passive solar home, what we really want to do is put good, heavy insulation on the outside of that and then bring that thermal mass inside of the house, so that those concrete walls of a basement, or it may even be above ground if they're concrete walls, I want that mass on the inside absorbing that heat and giving it back to me. Here's a house that steps up a side of a little hill here. This is in Santa Fe, New Mexico. And you can see it has a huge amount of solar gain in the winter in particular when the sun is low. Inside of the house, you can see the thermal mass in the floors, in the walls, all kinds of adobe and brick that's in there. Now, you think of that house, you go like, my goodness, it'll turn into an oven in the summer because of the sun shining through it. This picture taken on the inside is actually taken in the summer. The previous one that we had here, this is in a cooler part of the year, and then come summertime on the outside. Notice those louvers that are there. We put the shades on the outside of the glazing. See, if you put the shades on the inside, the sun will shine through the glass and then warm up those louvers and still give the heat to the house. In this case, these louvers are on the outside, so the sun will shine on them, it'll heat them up, but they're outside. We're still letting a lot of daylight in, but we're not letting the solar energy come in the summer. This is another way of reducing solar gain in the summertime, is by shading on the outside. In this case, they're movable. Put them up in the spring, take them down in the fall. Solar shading that we've just been talking about there, another way of doing that that's very automatic. You just take a look at this change in the sun's position. The summer sun being very high, the winter sun being much lower, and by having an overhang at the house and calculating it properly, it allows the winter sun to penetrate deep into the house, and then as you go into the spring and into the summer, as the sun is becoming higher in the sky, that overhang, that shade cuts it off. It's automatic. You don't have to do anything in this case. Other ways of shading would be exterior shade louvers that are on the outside. Notice on the left of this window, you can see the window has been opened. So the glazing is on the inside, the shading is on the outside, so we don't bring that heat inside. When you put your blinds on the inside, it keeps the sunlight from glaring in directly, but you still have the heat that's already comes from the glass and it's letting it collect inside of the house. You want your shades on the outside. Here's another one with exterior shading that is outside of the glass so you don't get the heat. This is particularly effective in desert areas. And here we are again back to the Karen Terry house with those exterior summer shades, these louvers that are on the outside so that you don't let that heat come in. All right, so we have ways of collecting it, just bringing it directly into the house, warming up mass inside of the house, whether it shines directly into the living area or it shines onto a wall. It's a very simple way of both collecting it and storing it. Now we need to distribute it. Well, distribution is pretty simple, and since this is a passive system, once again, we're going to move this heat by natural means. That'll be convection, radiation, and conduction. We'll use all of those. Now, we go back to our very simple direct gain house. We warm up the floor. We want to have insulation around the perimeter in particular, and we may include part of the earth as some of this thermal storage. When that floor gets nice and warm, it's going to radiate it back into the house when the sun is no longer shining. The other way of doing it, I mentioned this one, is a trom wall, where you'll take your mass wall made out of concrete or brick, put it just inside of the glazing, allow the sun to shine directly through. Usually the gap is about 6 to 8 inches. And then you have these penetrations at the top and the bottom that will allow the warm air to rise into the room and the cool air to come off of the floor. Here's a schematic of one of them, where you have your concrete or your block wall, double glazing, and you get this natural convection, this thermal circulation that's going on. Plus you also get radiation into the house, the thermal radiation that will come into the house. You see that there's a thermal lag time. When the sun shines on that concrete, let's say it's 10 o'clock in the morning until 2 in the afternoon during the biggest gain periods in the middle of winter, and it's shining on that concrete warming it up. It's usually painted dark. You're getting some of this hot air that's collecting in there that circulates into the house, but also that thermal mass is being warmed up. Now, it doesn't pass right through. As a matter of fact, the lag time is about 6 to 8 hours. So the highest temperature that's going to be on the surface of that concrete where the sun was shining on it, that finally penetrates through, and about 6 to 8 hours later, it's now come through to the inside of the house, and that just happens to be when it's dark, when the sun is down, so you're getting some of that radiation, that thermal radiation into the house, plus it's also gets some thermal convection going on the inside. Here's one of these walls. You take a look on the left over here. We're looking at the outside through the glazing, and you'll notice the bottom thermal siphon openings. The orange arrow points to them, both on the outside on the left, and then on the inside of that room, you see them there. And then up at the top, you have these ports that allow the warm air to come into the room. So during the day, when the sun is shining, it's warming up that air gap that's in there, warming up that concrete. Some of that air rises into the room, warms up the air in the room. As it cools, it settles down to the floor, and it's drawn back in through those lower vents down there, and that heat is then, that cooler air is then warmed up, and it circulates back into the room. This is natural thermal siphoning of the air. Warm air rises, so it rises up. As it cools, it settles down, circulates through the house. No pumps or fans needed for that. So you see this room looks fairly normal on the inside, except you have these holes in the door, in the wall, that allow the heat to go through it. Now, you may want to stop the reverse action. You see, during the evening, when the sun is gone, now then that air gap on the outside of the trom wall is going to get chilly, and so the warm air on the ceiling is going to be pulled in. It's going to be cooled as it runs down the glass, and it'll come into the room. You don't want that to happen. Here's a very simple way of taking care of that. This is an automatic thermal siphon reverse flow damper. Thin little piece of plastic that's taped on. I mean, it costs next to nothing. And as it tries to reverse siphon in there, it simply closes. And then when it warms up during the day, and once it is warmer on the glazing side on the outside of that than it is on the inside, that damper just opens up with the natural pressure of that air that circulates in. Very simple and just about free. No fancy valves or anything needed for that. Here's a cross-section, a schematic of a house that might have several things. You can see the direct gain through clerestories and window walls, through a collector down low on the left, and the air can circulate up through rocks and travel through the house. And I've designed and built some like this. They're a lot of fun. Still, no pumps are required for that, no fans or anything required. Now, if you have a fan, you can move even more air. In fact, very often we'll use a little bit of a fan to move some air. But when the utilities go off, it will still work just fine. One of the other things to consider in passive solar heating is that particularly in a very cold region, you'd like to build your house in as warm a spot as you can find. Well, in this case, we're talking about the Earth, because the Earth is going to be much warmer than the surrounding air. In the winter, you might have air temperatures that will be, 10, 20, 30 below zero. You get down 3 or 4 feet down into the Earth, and it's very stable temperatures, 56, 58 degrees, depending on where you live, up to around 62 degrees. So you build your house in a warm spot. We use the Earth to shelter the home. And in this case, you see the kind of the cutaway where you want this rigid insulation on the outside of the thermal mass that you would have on the inside of your home. Now, here's a berm wall. It's not the complete side has been covered up. This is a north side. You'd like to do earth berming on north and west walls, in particular west walls for the summer heat gain that you don't want to have, and then in the north for the winter loss. So it can be partially bermed, or you can even start burying the house completely. Here's another one in northern New Mexico where the house is almost completely covered in earth, and others like this. In fact, it almost looks sort of conventional on the one side, but yet the north and the west sides are quite covered up with the earth. You can have completely buried homes, completely earth sheltered. Another one right here using earth. This particular house has a sod roof on it. When you look at it right here, there is the earth that's on the roof, and the berming that's taken place, at least 4 feet up on the north wall. One of the other things to consider is where you would put the collection, the storage, and the distribution all combined into one in a very simple system for capturing, storing, and then giving that heat back. We call that a sun space or a greenhouse. These are a lot of fun. They're also great for heating, and they can help you provide food because now you have a place to grow things. This greenhouse effect, we hear a lot about that relative to the Earth because it actually is a very important part of maintaining the Earth's temperatures in the case of using clouds and water vapor. Now in our case, when we're designing something, we're going to be using glazing, glass or plastic. So you have the shorter wave radiation more in the visible range, ultraviolet to the shorter infrareds shine through the glazing, they shine on a surface, they heat it up, and then the process of heating it up, now then it's changing that sunlight energy into long wave infrared, and glazing, glass in particular, is very effective at reflecting that back, trapping it inside. Hence we have the greenhouse. You attach one of these to your home, and this is an excellent way of retrofitting an existing home on the south side of the home, and I'll show you a number of pictures of those, where you just attach a greenhouse on that south side. Now you have a sun space and a room and a place where you can grow things. You'll want to be capturing the heat, so you'll be using masonry. You can use drums of water, brick, rock, a variety of things like that. Notice on the lower left-hand side over here how you have the insulation that's on the outside of the masonry mass that would be a part of this greenhouse. Here's one of these little attached greenhouses, sun space, that's been added on. And in this case, it was added over the entry area so that you're reducing the infiltration into the house. This is what it looks like on the inside. Nice little green space. Now, it's not huge, and so it won't add a tremendous amount of heat to the house, but yet it's a place where you can grow some things, and you can, boy, these things are a joy in January to go out and sit inside of it. The outside air temperature is way below freezing. You're sitting in there, and it's 75, 80 degrees, and the sun's shining on you. This is an extreme joy in the middle of winter. Here's one that was added onto the south side of this house. And you take a look at the inside of it. Here's what it looks like on the inside. And a wonderful place to be growing plants. And if the conditions are right, you want to, you can be growing things throughout the winter. Other attached greenhouses, they can be simple. They can actually be fairly crude, and you might even think of them, well, as ugly. But, you know, it's not about the looks. It's about the performance that you're getting from it. It's the benefit that you gain from these. And particularly where budgets may be tight, you might not be looking for something fancy. You just want something that would work very well. Here's what it looks like on the inside with all of the greenery and the plants. A wonderful place to be in the middle of winter. Here's another one of them that looks, well, a little bit, this one doesn't fit the architecture of the whole neighborhood around there. They added this one on the house. This is in New England where this one was. It has this very nice greenhouse added to the side also. There's a big traum wall there, and then you have this greenhouse. Looking inside of the greenhouse, this is what it's like in the middle of winter. A very enjoyable place to be. Add-ons like this, simple, yet very, very enjoyable in the winter. This is a whole house that most of the south side of the house, the lower level, has this added on green space, sun space, that will add a tremendous amount of heat to the house, and also a very good, this is in Los Alamos, Mexico is where this one is. Looking inside of these sun spaces, all kinds of different looks and feels to them, very enjoyable places to be. That's what I love about them. This one right here with this large sun scoop, and when you go inside, this is what it looks like. Outside, snow and cold. Inside, it's an absolute, well, it's a very comfortable place to be with the sun, with the humidity, and all the green growing things. So I'm a real advocate of having things like this on your house, whether it's a house that you're building new so you can build the house around a sun space greenhouse as was done here, or it's something that you retrofit. Give you another concept, something that would be low cost and functional. This is a simple do-it-yourself retrofit, and it can be moved. We did a class on this one a while back. It was not recorded. because I was just developing the class anew. I used to do solar classes all the time as part of my consulting work, and we'll be doing more of those in training. We'll be recording that class in the future, and it's building what some people would call a pillow wall, an inflated wall like this. And this one that's been added onto this home, if I remember right, I believe this one's in Colorado, very similar to one that we did on my parents' house that covered a whole south side of the house, using an electrical conduit, the EMT, and then plastic that goes over top of it. Now, it's double walled, and you see it kind of looks like a pillow because it is, because it's inflated in between. Here's a big one that was added on, and you see how it billows out on the inside. Now when you look on the inside, you see how it's puffed in. That's because air is being pumped in between these two layers of plastic. This inflates it, keeps the plastic rigid so it isn't flapping and making noise in the wind, stabilizes it, also adds a little bit of insulation to that, and allows you to have this thing that's quite inexpensive. This kind of plastic sheeting, this is not your regular construction plastic sheet. This is it's used in greenhouses. You see these kind of greenhouses around, and it's UV stabilized so that it'll hold up. You'll get somewhere between 4 to 7 years out of this plastic in the sun, whereas you get your regular visqueen, and it's good for about 3 to 4 months, and then it will fail. It will break down. So now I have something that I spend for that glazing on there. This particular one, it probably has about $250, $300 worth of plastics on the outside. It'll run for about 7 years. If I wanted to make that all glass, I'd probably be spending upwards of $8,000 to $10,000 if I was doing it all with new materials. So it's a way of cutting the cost down dramatically, yet still getting wonderful performance. And here again, you see this thing in the middle of winter. What a place to be. So let's take a look at this one. This is the Shelter Class 6350, do-it-yourself attached sun space greenhouse. And just very briefly here, give you the concept. These are pictures that were just taken while I was doing this live for our students there in Linden. Building a frame using this plastic that's stapled, taped onto it. We have 2 layers on there. This inner layer that's stapled on the outside, taped onto it. I need to have a way of pumping air in between them, so I'm using just what I had around, a fan and a tin can that you cut and you attach them. And I showed very simple ways of attaching it through the plastic in here, then putting the outer layer of plastic over top of it. It is both stapled and taped, and then you have bat boards that go down over top of that that are screwed on so that this will hold up. Because if you're doing this with the plastic, it's going to be good for 7 years. I want the frame to hold up and the attachments to hold up. Here you see it with the air blown in between the two of them, and you see the pillow that's on there. The inside being the underside being pushed in, the outer side being pushed out. Uses very little electricity because that fan is running at a static cutoff head. It's just to maintain the pressure in there. There's no air flowing through it because it's a sealed space. That fan is just puffing it up to hold that plastic rigid. Here you see the inside with the plastic that is puffed in, and then on the outside it billows to the outside. So there we have a simple way of doing that. You can build those panels all along the south side of the house. Wanted to give you that concept because it's not expensive. You don't have to spend tens of thousands of dollars to do these things. A little bit of scrounging and a few $100s and some skill and some tools, you'd be amazed at what you can do and how much heat you could add to your house. In fact, I've got to find a bunch of slides that I have. I've never digitized them. The first one that I built and added to our home in Pleasant Grove, Utah, we had a 2-story one there. It covered a large deck that was over top of a double garage, and it went up 2 stories. And it was an absolute joy. I remember this was years ago when we had our kids there and still in diapers, and they're out there riding around on this deck in their tricycles in January getting a suntan. We would have barbecues. I'd go out, step outside and set up the barbecue out there, and I'd be barbecuing something out there, and it's like snowing and blowing. I'm barbecuing outside, bringing it inside to the picnic table. We're sitting around inside having just a wonderful time. You fall in love with these things once you have one of them. Now, if you're going to use one of these inflated pillow walls, you're going to need a little bit of electricity, and this is where having a small amount of photovoltaics would be very important to keep it inflated. Now, when the utilities are running, you just plug it into the wall and let it run that way. But when the utilities are down and that plastic goes slack, particularly if there's a blizzard of wind going on out there, it can tear the plastic. It's important to keep it taut. I was amazed at how durable it was. We had a few times just horrific winds blowing, and I thought, man, it's going to tear that plastic away. As long as the power was on and it kept that plastic nice and taut, it wouldn't get the flapping and jerking in the breeze, and held up very well. So this modest amount of electricity from sunlight would be something important to do, and that's where you'd have a small system. We're not trying to power your house. We want to run a fan, and I want to be able to run that fan through the night and perhaps through a couple of very, very cloudy days, keep that plastic taut. So a small system. We'll be repeating this solar power class in the not too distant future, so you can learn a little bit more about that and how and why these things work. So a little modified system to run the fan and some other appliances that you would have around the house could be very useful. Supplemental heat. This is something that you would want to have in your passive solar home. This is for off-the-grid applications, and you're going to back up your backups. You want to understand what your options are and have several of them. Well, one that a lot of people will use, of course, would be something like propane. Now, we might have natural gas right now, which does a great job, but what happens if the natural gas is off? You can store your own propane in tanks, and you would be able to run some radiant heaters, run stoves, and things like that, furnaces. Then you back that up with a biomass appliance. Biomass, wood, is the primary thing that you may in fact be burning. You could also be burning coal, depending on where you live and what you have access to. Now you have a way of both heating and cooking. So this is a wonderful backup option. You can have things that's just the fireplace. The stove is primarily for heating, again, to allow you to keep things, comfortable, keep the chill off of things. And if you have a house that's very, very efficient, because a part of the solar heating is to have a very efficient home, then having a little bit of wood burning appliances in there can do an amazing job keeping things very, very comfortable as a part of your backup. I'll take you on a couple of house tours here on some passive solar homes. Solar home that's in Sanpete County in Utah. This one's been in use for over 10 years, and it's very off-the-grid capable. It uses very little utilities now. If the utilities go away, it will be just fine. Here you can see some of the things that we've been talking about. This is the south side of the house. You have a lower solar collection area there. You have the sun space that's up above. It's a greenhouse sun space, and then clerestories up above. You look at the summer overhang to shade that lower area down there. And then it also has a solar chimney, a trick that I've used where you have something that in the summer in particular, you allow it to get screaming hot, heating up that air. That air wants to rise out of there, and so now it can pull the hot air out of the house. And very often we'll use an earth tube, which will be concrete or steel pipe, but I prefer to use concrete that's buried into the ground and pulls air through that concrete pipe, adds a little bit of humidity to it, and cools it down nicely, draws it into the house. Here again, no fans. It's all done with solar energy, with this thermal siphoning that wants to go on. Here's inside of the house. You see the upper clerestories. The sun space that we're talking about is off to the left, and you'll see these wooden channels. These are actually pipes that are in there. Here's the clerestory up above, and here is these thermal siphon air tubes, very large cross sections. They allow the hot air to come out of that sun space in there, and then circulate it into the north end of the where it can dump that heat and then draw the cooler air out of those rooms back up into the house. You see here the thermal mass wall, the concrete and brick on the inside allows the sun to shine on that. Here again is another picture of those thermal siphon tubes that allow that hot air to be drawn back into the northern areas of the house. Another picture of this house, and in this case you see the backup heat from this wood burning stove that it becomes very non-sunny, very overcast, very cold for long periods of time. Then this would be used to take the chill off the house. Very high efficiency, type of stove, you want it to be closed, regulate the air that goes into it, and you also like to have fans on them to help circulate the air. And as long as you have power, and this house does have backup solar electric power, so you can run that fan all the time. Here's looking to the east along the side of that house, the solar chimney at the west end, and the photovoltaic panels that are associated with the house. Here's another house in Sanpete County that's under construction. It's being built in phases. This is one of my favorite ones because I had a little bit of input into the concepts that are going to be used into this house. It can be done in 3 phases. Phase 1 is what's going on right now. House is to be completed for occupancy about June 15th of this year. Radiant floor heat, wood stove backup, gray water recovery system, full backup photovoltaic electric system. Has a moderate high, a good high thermal efficiency. The house is built well. And then the phase 1 initial solar performance. Now, I'm very conservative in my estimates. If you wanted to maintain a normal lifestyle, and that is, I want the temperature to be 72 degrees and I don't want it to fluctuate from that, so I'm going to be using my utilities to make up the difference. This house will carry, or all the solar will carry at least 30% of the heating utility. It may in fact be higher than that, but I'm very confident 30%. Now, if you'll adapt your lifestyle a little bit and allow the temperature to fluctuate in the house, and as a matter of fact, if the power was down, there were no utilities, and you had no backup, in other words, no wood stove or anything going on it, that house is going to stay above freezing, and that'll be in the worst part of the year when it's very overcast, very cloudy, snowy, and very low temperatures in our area that'll be below 0. That house will never go below freezing. It'll get chilly, 35 degrees, but it'll maintain very nicely, and that's without backup. Of course, now you turn on your backup, you can bring that temperature up and make it much more comfortable. The site location for this home, and then you see footings and foundations going in, this house rising. It's been a lot of fun to watch. It's in my neighborhood close by, so I can keep a little bit of an eye on it as it's climbing up, and you start to see some of the features about the house. Now, some of the features very, very important to me, something I wanted to see done. This is the basement. The tubing in the basement is for radiant heat. This is hot water, radiant or hydronic hot water heat in the floor. There's an insulation blanket underneath, tubes that are laid down, and then the concrete that's poured over top of that. Same thing upstairs, where you have the upstairs flooring, tubing that will be in the floor, and then concrete poured over top of that so that it will be heating that concrete. This is also part of the thermal mass that shines in through the windows upstairs and downstairs. You take a look at it now. This picture I took yesterday. The house is nearing completion. That's looking at the south side of it. And then it's this solar performance that we really want to look at. This has been kind of fun. Here's the basement sun penetration December 23rd, and you see through those lower windows it penetrates deep into the house. In fact, it go a little deeper because that plastic is covering up part of it. Going upstairs and looking down the stairwell in there, you see how it's coming more than halfway across the basement, all this wonderful sun pouring in on that insulated concrete floor that also has the ability to be heated with the radiant heat. Here we have on April 16th. Now then, we're into the spring. The sun is climbing higher, and you see that it's not penetrating very deep into the house. And then we come right up into recently, and you can see that during the summer, you have a complete sun exclusion that's going on. The sun will not shine through those windows at all. Totally passive. It's just calculating and using the overhangs just right on it so that when the sun is low, it's pouring inside, and then when the sun is high, it's being excluded by these overhangs. Nothing to move, nothing to break. It's all very automatic. Here's looking west along that south wall, and you can see the amount of solar gain, and of course that'll shine inside on that concrete floor that's upstairs, and then onto the concrete floor downstairs. And by the way, this concrete floor is when it's poured over wood like that. The upstairs, it is not as hard as you think it is because there's still a little give to it, still a little bit of flex. And then you use area rugs where you're going to be walking so that it cushions things a little bit. Now, here are some other features that are very important to this thing that I wanted to see done. Metal roof. This is for water collection. In this area, we live in a desert, and we want to capture water that'd be coming off the roof, and the metal roof is the most effective for that. If you have a shingled roof, whether it's wood or asphalt or any of those kind of things, the first eighth of an inch of rainfall gets sucked up into the roof itself. In the case of a metal roof, this is a turn pan metal roof, it all just wets the surface, takes very little wet the surface, it can run off and be collected. The other thing that's very important for this house, I believe for any house, is gray water recovery for watering. Gray water. Black water goes down the toilets. The sinks and the showers and the bathtub, that's all gray water. It has some soap and a little bit of soil and things in it, but it doesn't have any nasty pathogens in it. It's ideal for watering trees and shrubs and things like that. And we throw away so much of that water out of the washing machine, out of the dishwasher. When you turn on the water to get a glass of water and you let it run for 30 seconds to get cold water, you have all that wonderful culinary water that's going down the drain. Well, you really want to collect that, and then you can use that for watering, particularly in a desert area like where we live. Phase 2, some things that can be done to it and that are in planning stages. This lower sun space greenhouse, add that in. There's some phase 2 boost to the solar performance. And then in this case, when you do that, in normal lifestyle, this thing will carry 75% of the heating utility. If you'll adapt your lifestyle and say, and no backup, no wood furnace or anything, this house will probably never go below 45 degrees. That's almost getting up into comfortable. It's cool, but it's not terrible. Now, off the grid with wood backup, near normal comfort is what you'll have with that house. Then you take a look at phase 3, where you can add in for the radiant floor heat. You can now use some solar to heat that if the natural gas is gone, and or a wood boiler that'll augment the natural gas. You can improve the thermal efficiency of the home some more, an upper deck sun space, and then a little more boost in solar performance. And now at a normal lifestyle, the 72-degree thing, 90%, at least 90% of the heating utility to be covered. If you'll adapt your lifestyle and say, I'm going to allow this house to get down to 65 degrees, you'll be 100%. If you have no backup, I would predict that that house would never drop below 50 degrees once you've done these things to it. And with off the grid and where you're using the wood backup, it's easy, it's normal, and it would be very, very comfortable. Well, some ideas there about this spaceship Earth that's flooded with all the energy that we need every day flows to this Earth if we would just capture it. Some of these sun scoops, different styles, different architecture, different looks. You have to decide what it is that you might like to have, what you would be comfortable with. Obviously, it's going to look a little bit different because you're going to have more, glazing on that south side just because that's what you're trying to do. Interiors may look quite unusual or may look fairly normal, depending on the type of structure that you use, the type of finish. You can have attached greenhouses you would add to the home. You can have all kinds of different looks. This retrofitting is something that I consider important to do, because if you have a south side of a house and you can attach one of these greenhouses to it, even if it's a very simple, low-cost inflated one like this, the performance addition will be quite striking, and you can truly enjoy that sun space in the winter. Well, when that sun comes up, and something I hope that you think about is it comes up particularly in the cooler parts of the year and you feel that energy, striking you, boy, wouldn't it be nice to bring that into your house. That's something you can do. So if you take a look at this concept of the loss of the utility infrastructure, particularly we're thinking about heating, it really won't be a threat to you if you've done some things. Number one, you have knowledge of your options. You understand how and why things work. And if you remember, my formula for knowledge is K equals I times E. K, knowledge equals information multiplied by experience. You need to play with these things. If you have knowledge of proper equipment, how to operate and maintain them. If you practice now and enhance your conservation of fuel and power. If you're part of a true community where you can work together, you know how to scavenge some fuels and alternative kinds of things. If you can produce a little bit of electricity, not very much, just a little bit, and you're prepared to use solar energy for heat, and you have adapted your lifestyle, your thinking, to something that would actually be practical, rather than saying, I'm unhappy if I have a house that goes below 72 degrees. What if your house is 50 degrees? Put on some clothes. Of course, I talk about that an awful lot. Just allow the temperature to fluctuate. All of a sudden your utilities go down, and or you can be safe with fairly inexpensive systems, and you can still be quite comfortable when the utilities are all gone. So these are things to consider in your thinking, in your planning for the future. Well, as always, the mission has been to reach and teach as many people as we can. And some of these concepts, the principles of how and why things work. This was not a solar design class, but it was designed to let you know that it's both very possible, very doable, and to give you an idea what some of these things may in fact look like. Now, we have free classes every week. The internet audio cast that goes out on Tuesday nights, you can link to it through the newsletter, and of course through the website. We have our Wednesday night, which is where you are right now. We have these video casts we do. We have been most of the time live in person at Cabela's, because I've been kind of off a little bit here, got knocked off my saddle. I'm not traveling up there to do that right now, but we'll be back up there in the next few weeks. We have this video archive that you can go to the webcast. The one that we're doing tonight, it will be posted in the future. That's why we're capturing it, and we're going to be recapturing some of the others that were lost. So we'll have an archive that will have dozens of these presentations there available for you. Then there's the newsletter that will give you the links to the audiocast, webcast, and keep you apprised of other things that are going on. So these are things that we do to do our part to help you at Safe Harbor Alliance to live providently as you can. So the question is, will you live providently? Well, the choice is yours and mine, and if we will make proper provisions in all of the areas of our life, then we're able to face the future, and not with fear and trepidation and worry and hand-wringing and gloom and doom, but really with hope and with confidence. This statement that I think is how it really works is, there's just no doubt that tomorrow will come, and there's no dispute that things happen, but how you're prepared to meet tomorrow will make all the difference in the world. If you're prepared for the worst, then no matter what happens, it will be an adventure. That's the way that I believe it should be, an adventure rather than a struggle. So true preparedness is based on principles. That's why I like to teach how and why things work, not just here's a list, do this, because what you know is more important than what you have. And it really is about developing a lifestyle of provident living, where you test and try and have fun and play with, you gain experience and experiment with things, make some mistakes. Now's the time to break things. Now's the time to wear some things out, because you can fix them now. You make this a part of your lifestyle, and you do it for all the positive reasons, and you go do some of these strange things. You don't have to do what I do necessarily, but still you need to do some things perhaps you've never done before. Well, as we finish up right now, and I'll be glad to entertain any questions that you may have about this topic, you can type them into that question area, and I will do my best to answer them for you. And once again, this class is being captured. It will be available in the near future online for you to come back to, and or for you to send other people to. And we encourage you to bring people to the audio casts and the webcasts, and bring them to the archives, because our intention, our purpose, our reason is to reach and teach as much as we possibly can, because I'm not prepared until my neighbors are prepared. My neighbors just happen to be coast to coast, border to border, and beyond. Anybody that wants to learn, we're happy to teach them as much as we can and help you both get an understanding of how and why things work, but also help you understand the kinds of things, the material things that you need. I know as people, we think in terms of stuff. I want to get my hands on something and touch it and hold it. So we put into our stores our supplies and our tools and our materials, and you do want to have those things. It's important to have them. But it is, going back to that law of provident living, it is first and foremost that spiritual foundation. Next, having an attitude that says, I'll be okay even when things break, because I've made provisions for it. How do you have an attitude that says I'm okay? It's really knowledge. Knowledge, being information multiplied by experience, will provide the information, a lot of the information you need, and hopefully provide some of the motivation so that you'll want to go play with those things. But you'll have to gain the knowledge. That's up to you. And then the stuff, the material things, but with the right attitude and with the knowledge, you'll have the right stuff. You'll know what you're looking for, They'll also know how to replace it when something breaks, is lost, or you're separated from it. That's why what you know is so much more important than all the things that you may just happen to have. Well, this is Jim Phillips with Safe Harbor Alliance, and it's been a pleasure visiting with you this evening. Hope this information will serve you well, and we'll see you again in the near future. Have yourself a great evening. Good night.